welcome to the first in a three-part series of tutorials on algebra. And this particular first tutorial will be covering expanding out brackets. The second tutorial will look at the opposite process, which is factorisation. And then the third tutorial will cover using algebra to rearrange equations. And I know in particular that last topic is something that many students find difficult and confusing. So in that last tutorial in particular, I really want to try and make that as clear as possible so that you'll be able to rearrange equations confidently and not let that be a stumbling block. So these first two topics though, expanding out brackets and factorisation, they're sort of like opposites of each other. They're sort of like unwrapping presents and then wrapping presents. And I think we would all agree that as we go through our lives, our ability to unwrap presents starts relatively early on. Maybe in our, when we're like 3-4 years old, we're quite good at unwrapping presents. But wrapping presents takes a little bit more care, it's a bit harder. And so we don't probably start wrapping presents very well until, we're in our teenage years. And I think it's very similar with this. So I think expanding brackets is something that once you've got the hang of it is relatively straightforward. The opposite process, the wrapping part, which is putting things into brackets, maybe takes a bit more experience. So anyway, that's why we're starting with expanding brackets. So let's just start with some very simple examples. Let me imagine writing something like this. Now, when we're doing algebra, we have a mixture of numbers. Often, to be honest, those numbers are integers. And we have symbols. And these symbols may represent particular constants or they may represent variables. There are no fixed rules about notation. Generally, if you see symbols like x and y, those would typically be representing variables, and they would be involved in talking about some function that you could plot on the xy plane. But again, writing a and b, we don't have to worry what these are. These are just symbols, they represent something. The job of algebra at this level of maths is really just to manipulate these things. Okay, so in a crude sort of way, we're dealing more with the wrapping paper, going back to my metaphor on wrapping, than we are with the contents of the gift. So here we want to know how can we unwrap the gift, not worrying too much about what's actually in the box. And with factorisation, again, it's about how can we wrap that, so how can we manipulate the scissors and the tape and the paper, worrying not so much about what's inside the gift. So don't be distracted and say, well, what's A and what's B? That's not the point of the exercise here. The point is to be able to unwrap, and as we'll see in the next tutorial, wrap. So in unwrapping, the thing that you need to know about these brackets is that whatever is outside them as a factor applies to each and every term inside the brackets equally. And when you have a number in front of some brackets, this is shorthand for 4 multiplied by this collection. And by unwrapping, we would first of all take the 4 and multiply it by the first term. So we would have 4 times A. We respect the symbol here, plus, and then we take 4 multiplied by the second term. And that's all there is to it. So we have unwrapped this little gift here. 4 brackets A plus B is 4A plus 4B. Let me do another example like that. Let's say we have a symbol, F, multiplying 3 plus y. Looks kind of odd, but it's okay. We don't really worry what the symbols are representing for our purposes today. We're just going to expand this. So we multiply f by 3, and then we multiply f by y. Now, you see how I sort of wrote f times 3? That's just a sort of convention that if you have a number, and generally it's going to be an integer, multiplying a symbol, we just write 4a. Now when I multiplied this out, because I'm sort of trying to present this as simply as possible, I just wrote it as f times 3. But our convention is that if we have a term involving symbols and numbers, we then always put the numbers out front. So actually we're going to reverse the order of this and write it as 3 times f. And when we have the number before the symbol, we dispense with the multiplication sign. So this would just be 3f and then fy. And you might say, well, should we write that as fy or yf? I don't think there's really any distinction there. You might prefer to have those symbols in alphabetical order. If y really is a variable and f is a constant, then you probably would want to have the symbol representing the constant before the symbol representing the variable. Right, now let's move on to a slightly trickier topic, although actually let me just do one more example like this with a few more terms. So let's imagine we have a symbol and we have a mixture of numbers and symbols here. Okay, so we have a and then bracket 2 plus x plus s. So I would multiply this out. A times 2 I'm going to straight away write as 2a because the number will come before the symbol, just in terms of our convention. Then I have plus a times x, and finally plus a times s. Okay, and no matter how many symbols I had in the brackets, I just deal with them one by one. Now let's do something a little bit more complicated. Let's imagine we have a plus b multiplied by 2 plus x. So we have something in brackets multiplying something in brackets. Now the way to approach this type of unwrapping or expansion is to be systematic. So this is where we are not like the very, very excited 4-year-old on Christmas Day unwrapping gifts, which will not be systematic usually. This is more now like, I don't know what the metaphor would be with unwrapping gifts, because to be honest, at any age people tend to be a bit excited. So forget unwrapping gifts, we just have to be systematic here. So we just go step by step. So we take the first term in the first bracket and we multiply it by the first term in the second bracket. That's a times 2. Let me just write that as 2a. And then we take that first term and we multiply it by the second term in the second bracket. That gives me a times x. Then I have the second term in the first bracket multiplying the first term in the second bracket. B times 2, I'll write that as 2b. And finally, I have this term multiplying by x. So that would be b times x. And that's absolutely fine. I would recommend you do this in the sense that you take the first term in the first bracket and you just use that to multiply in order all of the terms in the second bracket, and then you go to the next term in the first bracket and use that to multiply all the terms. So let's actually jump to a really much more complicated example, but just to emphasize being systematic. Let's say we had a plus 4 plus y multiplied by 5 plus s. Okay, so now we have 3 terms in one of the brackets and 2 in the next. So we're just going to go term by term. A times 5 we'll write as 5a. A times s. And then we go to the next term. We have plus 4 times 5, which is 20. Then we go to the next term, and we have plus 4 times s. And then we have the last term, y times 5, which we can write as 5y, just because we like to put the number before the symbol. And finally, we have y times s. Now you can see from these last 2 examples why unwrapping is easier than wrapping, because it's relatively straightforward to multiply these brackets out. But if you were given this string of symbols or this string of symbols, it's not so obvious that you can factorize these in these nice ways, and that's why factorization takes a little bit more experience. Let's just do an example with some different signs. So let's say we have 2 minus x times y minus t. Okay, so we have some minus signs making an appearance now. This is where you need to be very confident with your rules for dealing with negative signs. At this level of maths, that knowledge is generally assumed, but I know it's something that some folks maybe find a little bit tricky, so I will try to do a sort of primer tutorial in due course on dealing with signs when you're adding and multiplying, dividing negative numbers. Okay. Right, systematic is the key. So first term times the first term, we have 2 times y. First term times the second term, we have to now look at the sign. This is minus t, so it's going to be 2 times, you can think of it as minus 2 times t, or you can think of it as plus 2 times negative t. Either way you look at it, it's going to be negative 2t. This next term, again, you can either think of it as minus x times y, so I mean negative x times y, or you can think of it as we're taking away the product xy. In either case, we will have take away xy. The final term, you need to think of this really as negative x times negative t, which negative times negative is plus, and so you'll have plus xt. So this might seem a bit confusing, and let me actually rewrite this in a different way that will help you. What we're really doing is this. We're writing it as 2 plus an object, which is negative x, all multiplied by y plus an object, which is negative t. So if you think of it like this, you can't go wrong, okay? Because now we have everything is plus, as it were, but some of the objects we've sort of put in bracket, little mini brackets here to emphasize that they have negative signs. So we have 2y, we have plus 2 times negative t, and 2 times negative t is minus 2t. Then we have plus negative x times y, and then we have plus negative x times negative t, which would be plus xt. And then you see we have the same as above, because plus of a negative number is just minus that number. So this might be quite a helpful way to think about when you have negative signs in brackets. If you're not sure exactly how to treat them, don't be afraid to just put these little brackets around a negative number. When I'm teaching, sometimes I make a joke that negative numbers can be sort of toxic. They can cause you all sorts of problems. And these I often call little biohazard containers. So we put our toxic thing into a biohazard container, and that way it's nice and safe and we're not going to have any problems. We can just deal with it very safely in a contained way. Right, that's fine. Let me just do a bit of expansion now with some cases which are good to remember. So let me write a plus b times a plus b. So here, this is relatively straightforward for us, but you see it has the same term. So this is, obviously we could write this as a plus b all squared, okay? And if we just multiply this out, we have a times a is a squared, a times b, plus b times a, and finally b squared. And so finally we can combine these two terms together, because b times a is the same as a times b. It doesn't matter which way round you write the symbols. So we have a squared plus 2ab plus b squared. And that is an important result, and that is a result that I certainly recommend you commit to memory. When you have the sum of two terms all squared, you get the first term squared plus twice the product of the two terms plus the second term squared. Let's do a take away b squared. We would have a minus b times a minus b. We have a squared. We have minus a times b. We have minus b times a, and then here we have negative b times negative b is plus b squared, and we have a squared. Again, minus ba is the same as minus ab. We can always switch the order of symbols that are multiplied together, as long as they represent numbers actually, because later in maths you'll come across objects where the order is important, but that's nothing you need to worry about right now. For our purposes we can switch these around, and we have two lots of negative ab, so minus 2ab plus b squared. And you see the only difference between these two is the sign of the central term, the kind of the mixing term. And again, these are both things that you should commit to memory. And then there's one last one that I think is worth bearing in mind, which is, what about if we have a plus b times a minus b? Well, this is an interesting one, because we have a squared, we have minus ab, and then we have plus ba, and then finally we have plus b times minus b is minus b squared. And now you see that the ba is the same as ab, and so we have minus ab plus ab, and those two terms cancel, and we're left with a squared minus b squared. And I would also recommend that you commit this one to memory. This is called the difference of two squares. And if you have the difference of two squares, the reverse is that you can always write it as the sum times the difference, okay, of the terms. It's not at all obvious until you've seen it in this direction that you can go the opposite way too. Right, okay, so I think I'm going to just end by doing one last little bit of expanding, and that's just to show you that if you have repeated terms, you can sort of collect things together. So let's just have a look. Let's imagine we have something like x plus 1 times 2x squared plus 3x minus 4. Now, we only have one symbol around, which is x, but we see that it appears to different powers. We have numbers where there's essentially no power. From the tutorial on indices, we know that we can sort of think of x to the 0 lurking around, which x to the 0 would literally be 1. Okay, so this is like 1 times x to the 0. This is like 4 times x to the 0. Then we have x to the power of 1, and then we have x to the power of 2. And we have to treat the different powers of x as different objects. You can almost think of x to the power of 0 as an apple, x to the power of 1 as a pear and x squared as a banana, and they're different kinds of fruit, and we can't combine them. Okay, you'll see what I mean in a second. Let's multiply this out. So I have x times 2x squared will give me 2x cubed. I have x times 3x will be 3x squared. And then I have x times negative 4, which will be negative 4x. Banana, pear, apple. Then I have plus 2x squared plus 3x. And then finally 1 times negative 4 is minus 4 there. So if this was, well, I shouldn't have said banana, pear, apple, should I? Because I was saying that apples are numbers, pears are x, and bananas are x squared. So I apologise. It's actually a terrible fruit analogy. What I really want to point out, though, is that we have to treat x cubed as a different kind of object to x squared, a different kind of object to x, and a different kind of object to a number like 4. But the key thing is that when we've expanded these out, we see that we have two objects which are similar, 3 times an x squared and 2 times an x squared. These we can combine. And then we have two objects which involve x. These we can combine. So this is sort of a simplification step. It's not factorizing, but it is combining terms of like type. So finally then, we have 2x cubed. We only have one term involving x cubed. These two terms involving x squared we can combine. We have 3 lots of it plus 2 lots of it. So that gives 5x squared. Then we have 2 terms involving x, negative 4 lots of x plus 3 lots. That gives us negative x. And then finally we just have that solitary number at the end, and there's nothing to combine that with. So when you have this kind of expansion, you see that there are terms that can be combined, and so when you do expand out brackets, always look to see if terms that you end up with are of the same type and can be easily combined. Sort of like we did here, where we saw that we had an A and a B, an A times B and a B times A that we could combine. So that's expanding brackets, and I think this is all about technique and sort of notation, that we put numbers before symbols and so on, how to deal with negative signs. These 3 I would encourage you to commit to memory, okay? Because if you see a pattern of something squared plus 2 times that thing times another object and then plus that other object squared, that's actually telling you that you've got the sum of the 2 objects all squared. And similarly for these other 2 cases. Right, I hope that's helpful, and in the next tutorial in algebra we'll be looking at the wrapping, looking at factorization. So I'll see you then.